Hi, my name is Naren Kumar Konchada, and we are we are Team 13, and our project name is Smart Movie Recommendation System. This video is a demonstration for Deliverable 4, which consists of SparkQL query and building of basic user interface. To proceed forward and demonstrate how we constructed the SparkQL queries, firstly we were instructed to host our data sets in a separate physical locations. So we'll go forward to going to the explanation. So as you can see here, we use the Google Cloud Platform to host our three instances, basically our three data sets. Through so we have one data set for movie lens, which is hosted in instance one for IMDb, which is hosted in instance 2, and one for TMDB, which is hosted here. And we made sure all of these are different instances. So we got separate IP addresses for this. So what we did was when we hosted them, the database datasets into separate physical locations, we next step was to host our Fisaki server there and make it running. So in order to do that, we use the console and we use this method. This is the instance for TMDB, as you can see here, TMDB instance. And you can see we have made sure this commands, we have uh, use the Apache Gina Fisiki here, and then we ran the jar file here. So the server, the instances got running here. So in similarly, this is for TMDB, and similarly, there are two more things. This is for instance one, which is the movie lens, and the other one is uh, this is for instance 2, which is for IMDb. So all the three instances are up and running here, even the servers. So next go forward and open up this uh, Fisaki server. If you can see here, the first instance, the movie lens is uploaded here. The dataset is already intact here, and this one is IMDb, and this one is for TMDB. So all of these are the Fisaki servers are up and running. So next step was to use the Jana API in a Java-based project, and then to build the backend of this application and to write the SPARQL queries there, so that the queries can be executed and the results can be found out. So if you come to the backend application, basically we are using the Spring Boot application for exposing, for getting the results from the SPARQL queries, and then expose this as in a form of APIs to the front end. So the basic Spring Boot application here, we use the particular following files. The major file here is the controller file. Controller file which will receive all the API requests from the front-end application, which we are planning to do it in Angular. So the front-end application would use this port and communicate to the back-end application. So basically, first let's go to the number of files we have. So the controller file is basically the one which receives the get requests from the front end. Movie is the class file which contains all the attributes that a particular movie needs to be displaying to the user. So this contains all the genre information, title, TMBB rating, and as well as the cast, as well as number of nominations. So basically, all the columns from the datasets become attributes here. So this class file contains the methods and getter setters as well. Next, Fisiki TMDB. So this one contains the TMDB contains the execution of query on the TMDB dataset. So we'll come back here. So this is one of the class file here, and this is the movie lens class file, and this is the Fisiki IMDB, where three separate queries have been written to target three different uh, data sets. And to move forward, firstly what our application does is whenever a person types in a movie name in the search bar, the movie variable here will capture that movie name, and firstly that Fisaki ITMDB would get called. So whenever this line is getting executed, so that a movie name variable in Fisaki TMDB is getting called, is getting assigned, and then here, when the Fisaki TMDB get results is called, this method in TMDB is getting called here, this method. So basically, the federated query, what we are doing here is once the movie which the user enters through the search bar is coming, the movie would be coming, the first query that would be executed is the inner query, which the movie name would be coming here. So this particular query which needs to be running on the movie lens dataset. So this is the URL there, which is the physical location as well as the dataset path. And then whatever the results we are getting from the movie lens dataset, basically the TMDB ID, that TMDB ID would be passed on to the next query here, the outermost query. So depending on these things, we expose or we get the results from the TMDB dataset. So this TMDB ID from MovieLens would be used here in TMDB ID for the TMDB dataset, and the following results are expected outside. So title, genre, TMDB rating, vote count, cast, director. So these are all the information which we're getting from the TMDB dataset. So nextly, in the similar way, we need to get the some of the information which is not available in TMDB. We need to get those information from IMDb. So in the same way, when the movie name is typed in search bar, this movie name is variable comes here, and then from that we'll get the IMDb ID. From the IMDb ID, we get the further results from that dataset. So the select will get title, genre, IMDb rating, rating count, which these fields are different from the TMDB dataset. So next, so these shows us the linking between the data sets of MovieLens and IMDb separately and MovieLens and TMDB separately. Now, what our project is, we need to recommend to the user some of the movies which he sees. So for this, we are actually using the content-based recommendation system. So if you see that our recommendation system basically works like when the all the information which we get from TMDB and IMDb gets populated, that is only for visual purpose. After that, what we are trying to get is from TMDB we will be getting the TMDB rating, from IMDb we will be getting the IMDb rating, and from MovieLens itself we will be getting the user rating. So we would combine all these three and we would take an average rating for all the ratings available across three data sets, and using that rating we would suggest the users which in a range that these are the particular movies which are falling under that range. But that would be a major output, right? So we are suggesting the movies with respect to genre matching as well. So all these things which I have depicted and which I have communicated would be using in this query. So what this query actually does is, before this I have talked about the average and all, right? So that is mentioned in the movie controller. So when the results would get from the TMDB and the IMDb, then if you see here, we are doing the IMDb rating, which is by 2, because we are doing the downscaling because it was rating was given for 10, and similarly TMDB rating we are downscaling because also it was given for 10. Average user rating, this is the rating which we will be getting from MovieLens dataset. So all these three would be combining and averaging it by 3. Then this particular average rating would be passed to the next class where we need to get that results from. Now that would be hit in the movie lens uh, movie lens query. So here if you see the average rating which I mentioned there, the average rating here what we have taken is, if the range is the average rating plus 0.5 and minus 0.5. So the range which is plus 0.5 and minus 0.5, including in all those the rating that falls, the movie that falls in that rating, that is will be suggested. And also we use the regex function as a filter here to select the movie on the genre basis. So let's say we have selected a horror genre and a rating of a movie is 3, then the movies suggested would be in the horror genre as well, and the ratings would be 3.5 to 2.5. So that would be the results which would be getting here. So this is the Spring Boot application consisting of the 3 queries explaining what are the results which we wanted to get through the federated queries, by which we achieved the functionality of linking between different data sets. So all this has been done using the backend, using the Jana API, which was provided to us, as well as following the tutorials provided in the class. And if you go forward and then if you see Postman, this is the actual result which would be getting. But we would run the result again. So we would take this, and if we run a query like this, and if in this get method, as you can see here, the Jumanji 1995 is our movie. This would be coming from the front end when the user selects through the search bar. So as of now, we give this as backend, we give this as a get request, and we give send. So now actually this would take, as our data set is huge in number, this would take around more than 3 to 4 minutes of time. So that is when we should be uh, waiting for this to happen. So finally, when all this results comes, and then when the a particular nest site results is decided, then the result would be something like this. Yeah, this would be the result of the final output which we were expecting from all the queries. So just to see the visual perspective of this, let me copy this, and then we'll see this on the uh, JSON formatter. So if you see this and process, yeah, so you see here, this is the final expected results, which consists of average user rating 3.4, the title itself, whatever we gave, and the TMDB rating from the TMDB dataset, genre information as well, vote count, the cast information, overview, runtime, tagline, IMDb rating, ratings count. So all this information is displayed, and apart from that, our goal of the project was to recommend movies, so that is also being achieved here, as the movies are listed here, and we are displaying only the top 10 movies. Basically, we are limiting by 10 that are falling in the range and which are matching the genre as well. So this is the Sparkle queries execution from 3 different physical spaces, and the end results have been achieved. Going forward, our prototype was something like this. So we plan to do this as an Angular front-end application. So whenever a prototype, something would be like this. Whenever a search is done for a movie, all the information for that movie is displayed here in that particular card or a box, and then follow up to that, the 10 number of movies which are recommended to the user would be following below that. So this is our rough prototype, or the UI prototype for our project. And also, I need to mention about the overall architecture of the project. So overall architecture would look something like this. The front end is the client application, which is the web application, which is the Angular application. Backend would be the Sparkle endpoint or the Spring Boot application, which is the backend, and the Google Cloud instances. As I've already mentioned, we have hosted in Google Cloud, which is the VM1, VM2, VM3, which shows movie lens, IMDb, and TMDb. So this is our entire project, and all the necessary things, whatever we have gone through, the challenges, everything will be mentioned in the report as well. Yeah, thank you.